Hi everyone, I'm Effy Fang, a data scientist at Kumo. Kumo is a platform for anyone to train and run state-of-the-art AI models on their relational data. Our platform leverages graph neural networks and relational deep learning to let you build highly accurate, predictive, and embedding models without any feature engineering. In this video, I'll demo how a manufacturer can use Kumo to predict product demand. You'll learn how to start Kumo as a Snowflake Native App, connect your data, build a machine learning pipeline by constructing a predictive query, train and evaluate models. You'll also learn how to productionize your model as well as shutting down the app at the end. In this demo, we're going to use the TPCH sample data from Snowflake. You can find it under the Snowflake sample data database or create it yourself by executing the SQL commands in the user guide as account admin. First, you'll need to start the Kumo native app. The instructions, including the script for creating and shutting down Kumo, are available under the About the App tab. Run the startup script in a worksheet to create a compute pool and launch Kumo. Wait for the containers to spin up and return an endpoint URL. Copy and paste the URL in your browser and log into your app using the same Snowflake credentials. Like any ML tools, the first step of using Kumo is to establish connection to your data source. Kumo's Snowflake Native App integrates into your Snowflake environment seamlessly, providing a secure and direct access to your Snowflake data. Go to the Connectors page to configure a connector by providing your account identifier, warehouse, schema, and database name, then move on to Add Tables. There are 8 tables total in this TPCH dataset. To start simple, we'll only use half of them for this demo. Make sure to select the connector you created previously and click Source Table dropdown to choose the table you want to connect. Start with Customer Table. Select Customer Key as primary key. Kumo already inferred the column types, but you can make adjustments as needed. For example, change the phone number and hashed address to categorical and click Add Table. Connect Orders Table next. Choose Order Key as primary key and Order Date as create date. Click Add Table to save. Click Add Table again and choose Part Table next. Select Part Key as primary key and Add Table. The last table you need to connect is Line Item. For a fact table like this, primary key is not needed. We'll use Ship Date as create date. Setting a create date helps prevent data leakage. You're now ready to move on to the next step, creating a graph. Click on Graph to create a new graph. Give it a name, select the 4 tables you just created, and click Next to set up the links. The Customer Cust Key column should link to the Orders Cust Key column. The Orders Order Key column should link to the Line Item Order Key column. The Part Table Part Key column should link to the Line Item Part Key column. Confirm the links look good, and then save the graph. Now you're ready to start training a model. Click New followed by Model to start configuring a new training job. Select the graph you just created to use for this training job. You'll build a machine learning pipeline by writing a predictive query. A predictive query is a declarative syntax used to define a predictive modeling task in Kumo. It specifies the target variable to predict and the data context for training. It consists of a target, what you want to predict, an entity, who you're making predictions for, and optional filters, which are constraints on which entities or data to include. To predict the demand of each part in the next 30 days, we define the target as sum of quantity in line item table in the next 30 days, and the entity as all the part keys in the part table. Kumo then generates a model plan using AutoML. It automatically selects the best GNN architectures, column encodings, and training table generation strategy based on your dataset and predictive query. You can view and modify it under Model Settings. For example, you can change the train test split strategy, increase or decrease the number of experiments and epochs, adjust the neighborhood sampling strategy. After finalizing the model plan, click Start Training to kick off the training process. Use tags to organize your training jobs for easier retrieval. During training, Kumo searches for optimal architectures and hyperparameters, running multiple experiments. Each experiment is trained on the training data split and evaluated on the validation data split. The best performing configuration is then fully evaluated on the holdout set to generate final performance metrics. The entities in your relational data are first transformed into a graph, and then the GNN uses a message passing mechanism to take a target entity and its neighbors and all of its interactions, transferring all the context into embeddings, and then it layers an objective function depending on the predictive task. The architecture enables you to tackle a wide variety of machine learning problems on your relational data, from turning it into a graph. In this example, a target entity is a product part in the part table. Kumo first extracts all the surrounding information, including the attributes of the product, which customers bought this product from which suppliers. When were the past orders made? What other products were purchased with it? From the other tables in the graph to generate the embeddings. Then it applies an activation function which we can choose to experiment among GLU, ReLU, and all the other commonly used ones on the output layer to produce the prediction of demand for next month. Once training completes, you can view the results under the Training tab. Use the charts and stats displayed under the Evaluation tab to evaluate model performance. Kumo selects evaluation metrics based on the predictive task type. For a regression task, it shows mean absolute error, mean square error, and root mean square error by default. You can also add other commonly used metrics such as mean absolute percent error by editing the model planner. It also plots predicted versus actual values and the distribution of the predictions for comparison. The Explanation tab gives you some insights into how the model arrived at the final predictions for a subset of the target entities. For a given entity, you can see how much each piece of information influences the final decision, coming from the entity itself and its neighbors, by checking the importance score. You can also access the holdout set for further analysis. Copy the comments under Evaluation tab to a Snowpark worksheet. Click the Run button to read the prediction into a data frame and display it in the results pane. To productionize your model, click New followed by Prediction to create a batch prediction job. This will allow you to use a trained model to make predictions on new data. Select the model you just trained and specify the output location. We will persist the prediction results as well as the embeddings to the same Snowflake schema, using the connector created at the beginning of this demo. Once it's done, you can see both the predictions and the embeddings table in Snowflake. Congratulations, you just went from raw data to predictions in lightning speed. This would have taken weeks to achieve without Kumo and Snowflake. There are many more use cases you can do with this sample dataset. For example, try to predict which customers will churn, meaning not ordering any part next month. Give it a try by yourself. When you're done, remember to run the script provided in the documentation to shut down your app.